What's up, amigos? Today we have the aerodynamics of a dice again being thrown, but this time it is rolling in air because, as you throw a dice, it tumbles. The simulation we did a couple of weeks ago was a stationary dice. So that's like if a guy is trying to stack the dice's outcome, whereas this is a little bit more fair where you just throw the dice and let it fall where how it may. And we use an immersed boundary method to rotate the die around. And we can see that the flow is very chaotic. So I've got the Y plane. It's just on the outer edge of the dice as it's rotating. And even at this point, there's a huge amount of wake. So you can see that as the dice rotates around, it transitions between a fairly, like it's almost like a von Karman street to them being quite symmetrical and then going back to a von Karman street periodically as the dice rotates, depending on where the edges are. And now we have the Y plane, which is going pretty much halfway through the die. So regardless of how the dice is rotating, there's effectively an unsteady von Karman street occurring all the time. It just really depends on if the dice is like diagonal, then the width of the wake is much greater, as you'd expect. But it's nice to see this periodicity to the wake shedding. And now this is a view from the top. So the other two views were from the side. And this means that the dice is rolling into the page. And this is an interesting view because even though the width of the dice pretty much remains the same as it rotates along, the leading edge, changes the angle. So you can see when you first start, it's more towards the bottom of the screen. As you progress through the simulation, it moves towards the top of the screen. And this changes where the leading edge is, obviously, but then how the wake reacts to that. So as you continue along in the simulation, because that leading edge moves to the top of the screen, the wake also then moves to the top of the screen as well a little bit because it's facilitating the redirection of the flow. And this is just creating a bigger wake. It dictates how the wake is being shed from the rest of the dice. So that's the simulation. Make sure to like and subscribe. And if you have any ideas on what you want to see simulated, let us know in the comments below. And if you want to get better at CFD yourself, so for example, doing an IBM, Immersed Boundary Method with a dice, check out the link in the description. We do CFD courses. And I'll see you in the next simulation. Peace out, amigos.